Part 1, Opening Dataset, Modifying and Examining Variables. Today we will be using data from the National Electronic Injury Surveillance System. This dataset is on fireworks-related injuries from the years 2000 to 2010. As you can see right now, I'm running the libname statements that I can input or pull in my dataset. And right now you can just check and see if that dataset is there, if the libname statement was properly ran. One of the first things that you would like to do is just examine the overall data set, see if the contents there are correct, and if the variables are correct. As you can see, you can look at the overall number of observations here. As you can see, we have 1,248 observations of 26 variables. You also may look at the type of variable, whether it's numeric or categorical, from running proc contents. The next thing that you may want to do when starting new with the data set is modify certain variables from being numeric to being character. As you can see, this is one data step that you could run. As you can see, I changed my numeric race variable to a categorical race cat variable. Next, we can examine the distribution of categorical variables using proc freq. As you can see, I'm running that here, and I ran that on all the variables that are considered categorical, whether they have a numeric value or not. These are the categorical variables. You see the distribution breakdown for each one of those: gender, race cat, age, body part, and diagnosis category. And I believe we have severity, injury severity down here at the bottom. Oh, and we also have the type of firework related injury as well. Part 2, examining continuous variables. So when you have a continuous variable, you want to examine the overall distribution of this variable using proc univariate. And you can do that, as you can see, using the var statement, and then placing the variable of interest after that, then running that code. As you can see, we have the basic statistics of that age variable with the mean, median, mode here. We also have some standard tests for normality. As you can see, the Shapiro-Wilk test would most likely be used in this case with less than 2,000 observations. And we also have a QQ plot for age down here as well. Part 3, comparing distributions by categorical groups. If you want to compare the distribution of categorical variables by a group variable, you may do that with proc freq using the code like here. Okay, so after you have ran the proc freq by the race or whatever exposure group that is categorical that you're of interest, and looking at differences by other variables. As you can see, this output gives you the chi-square value and a statistic, a p-value that's associated with that. And you may actually encounter a problem where you have some cells that are less than 5. In that case, that's when you want to run the exact method. Just be aware that this method uses a lot of CPU time. So I would. Part 4, examining continuous normal variables. Okay, when looking at a continuous outcome variable and a two-group comparison, you use the proc t-test to look at the differences between those distributions. As you can see, this is the age variable. It is not normal, but we're looking at this as an example for continuous. Then you can look at either the pooled or the saddle wave statistic, and as you can see, these distributions are not statistically different from each other by using this test. Part 5, performing comparisons with non-normal continuous variables. When dealing with comparisons of non-normal continuous data, you may use the proc non-par one way data step to run a non-parametric ANOVA analysis, which will allow you to actually ask for the Wilcoxon or Kruskal-Wallis test, which is here. And as you can see, there is a significant difference between the groups. Part 6, obtaining summary statistics. There are a plethora of different ways that you may obtain summary statistics. You may use proc means, proc summary. I actually use both as an example, and you get the same values here. Part 7, comparison of two or more groups with normal continuous outcome variables. When you want to look at a outcome variable that's continuous and you have two or more groups, you may use proc ANOVA or proc GLM. There are also other statements that you can also use to compare those differences. Here I run it, and as you can see, I get the same p-values for both the proc GLM procedure and the proc ANOVA. Comparison of two or more groups with non-parametric or normal outcome variables. All right, as we saw earlier, age is a non-normal variable, so we actually should run the non-parametric version of ANOVA, the Wilcoxon rank sum test, to see the differences between groups, and it gives you the Kruskal-Wallis or the Wilcoxon test here. And as you can see, there are differences between bonus footage, performing pairwise comparisons with continuous outcomes. What if we wanted to determine whether there are pairwise differences among more than two group variables? We must run post hoc analysis to perform multiple group comparisons. This can give us statistics such as the Fisher's least square differences, or the LSD, or the Tukey's test. I'm again running this using proc ANOVA or proc GLM. You simply put the mean statement, and it will give you those overall comparisons. As you can see, this outcome looks very similar to running the proc ANOVA, but it also gives me the pairwise comparisons or differences between groups right here. As you can see, black is different from other, black is different from white. And here, there's the Tukey's test, and as you can see, black is different from other, and black is different from white. And again, using GLM's procedure, same results.